module, we will examine the air conditioning and pressurization systems of the aircraft. First, we will start out with a brief system description. Next, we will look at the air conditioning packs. After that, we will go over the air ventilation system. Next, we will explore the pressurization system. Finally, we will review the controls and indicators associated with each system, as well as some limitations. The air conditioning system consists of two packs located in the main landing gear fairings. The job of the packs is to provide conditioned air to the cabin for comfort and pressurization. These packs operate independently of each other. The operation of the packs is completely automatic. An external air ground card can be plugged into a connector located on the right side of the aircraft. This card supplies conditioned air directly into the aircraft. The packs take bleed air from the pneumatic system and convert it into cool air, which is circulated through the aircraft via a system of ducts. The left pack normally supplies both the flight deck and the passenger cabin, whereas the right pack normally supplies only the passenger cabin. In the event of a failure of either pack, the remaining pack will supply both compartments through the mixing chamber. After the pack valve, bleed air is conditioned by the air cycle machine, or ACM. There is one ACM on each side of the aircraft. The purpose of the ACM is to adjust the air to the proper temperature for the cabin and flight deck. This air then flows into a mixing chamber located under the floor of the aircraft. The mixing chamber mixes ambient cabin air with air from the packs. The mixed air is then directed to the proper zone. Conditioned air is distributed from the mixing chamber to the cabin through overhead ducts, which route the air to individually controlled eye-bulb vents. Air from the cabin is evacuated through guides, located along the floor on the left side of the cabin. From there, part of the air returns to the cabin via recirculation fans. The remainder of the air is exhausted overboard through outflow valves, located on the underside of the aft fuselage. The lavatory is ventilated through a vent line. Airflow is generated by cabin differential pressure. Cabin pressurization is maintained by constricting the amount of air that is exhausted overboard. This is accomplished by modulating two outflow valves between open and closed positions. The outflow valves are located on the bottom side of the aft fuselage. Controls and indicators for the air conditioning system are located on the overhead panel. The status of the air conditioning system is displayed on the cabin page on the multifunction display, or MFD. Pressurization system information is also displayed on the cabin page of the MFD, below the air conditioning system information. The pressurization system is controlled by two control panels, located in the center of the flight instruments panel. The air conditioning packs process pneumatic air supplied by the left and right engines. Pneumatic air flows through the bleed valves, down to a pack valve on each side of the pneumatic manifold. The pack valves are electrically controlled and pneumatically operated. In other words, pneumatic air pressure is required in order for a pack valve to open. The pack valve is a butterfly-type valve. The purpose of the pack valve is to shut down the pack when required, and to maintain a constant pressure of air supply to the pack. Both pack valves require DC power from the DC essential bus in order to work. In the absence of electrical power, the pack valve will automatically close. In addition, the pack valve requires pneumatic air pressure in order to open. In the absence of air pressure, the pack valve will also close automatically. Pneumatic air is produced by each engine. This air is tapped from either the high-pressure HP stage or low-pressure LP stage of the engine, and flows through the bleed air valve. Therefore, the bleed air valve must be open in order for an air conditioning pack to function. The pack valve has two modes of operation, normal flow and high flow. The mode of the pack is determined by the position of the flow push button on the compartment temperature panel. When the flow push button is released out, both pack valves will deliver a constant 22 psi of pressure to the packs. When the flow push button is pressed in, both pack valves will deliver 30 psi of pressure to the packs. The high caption in the push button illuminates blue. The increase in air pressure available to the packs will increase the flow of conditioned air produced by the packs. In other words, more airflow coming in will mean more airflow going out. After the pack valve, hot pneumatic air flows through a primary heat exchanger, located in a rudder duct. This duct is located in the landing gear fairing. The scoop for the rudder duct is located at the front of the landing gear fairing. Air flows through the rudder duct, over the heat exchanger, and is exhausted overboard. This exhaust is located on the bottom of the landing gear fairing, just forward of the landing gear. In the event there is insufficient airflow for the heat exchanger, a ground cooling fan will draw air from the ground inlet and blow the air over the heat exchanger. The inlet for the fan is the same rudder inlet the heat exchanger uses. Air is then exhausted overboard using the same exhaust that the rudder duct uses. This ground cooling fan is powered by pneumatic air through a turbofan shutoff valve. The ground cooling fan is powered by an impeller, which taps bleed air downstream of the pack valve, but before it reaches the heat exchangers. This air is controlled by the turbofan shutoff valve. The turbofan shutoff valve automatically opens anytime the airspeed is less than or equal to 150 knots, and the landing gear is extended or retracted for less than 10 minutes. Therefore, the ground cooling fans will operate for 10 minutes after gear retraction, provided the airspeed is less than or equal to 150 knots. The turbofan shutoff valve is closed anytime the airspeed is greater than 150 knots, as this produces sufficient airflow over the heat exchanger via the rudder inlet. If an engine is experiencing low oil pressure, the turbofan shutoff valve on the opposite side will automatically open, and the associated turbofan will run at all times, as long as the airspeed is less than or equal to 150 knots. This will occur regardless of the position of the landing gear. If the turbofan shutoff valve is not in the commanded position, the associated pack valve will automatically close to protect the pack against any damage. After the primary heat exchanger, the cooled pneumatic air will flow to a compressor. The compressor section increases the pressure and temperature of the partially cooled bleed air. This compressed air then flows to the secondary heat exchanger for additional heat extraction. The secondary heat exchanger is also located in the rudder duct. It uses the same airflow as the primary heat exchanger for cooling. The air that flows from the second stage heat exchanger is used to power the turbine, which originally compressed the air the first time through. Upon reaching the turbine section, the hot compressed air undergoes a rapid expansion, which decreases its temperature dramatically. Airflow into the turbine is controlled by the turbine inlet control valve. The cold bleed air produced by the turbine then flows to a condenser. This condenser extracts moisture from the air exhausted from the turbine section of the pack. The dry air from the condenser then flows to a mixing chamber. The condenser uses the cool compressor air that flows through the secondary heat exchanger. This air flows through the condenser, and then flows through a water extractor which removes moisture from the air. From there, the air flows through an expansion turbine which rapidly cools the air. Temperature control is achieved by mixing bleed air tapped just downstream of the pack valve, with air produced by the expansion turbine. The amount of bleed air used is controlled by the temperature control valve. The position of this valve is set either by the electronic controller, or directly by the compartment temperature selector knob on the compartment temperature panel. This panel is located on the flight deck overhead panel. The operation of the air conditioning system is controlled by the temperature selection push buttons. The automatic mode is selected when the push button is pressed in. In this mode, the electronic temperature controller will control the position of the temperature control valve, based on the temperature selected by the associated compartment temperature selector, as well as the pack supply duct temperature, the aircraft skin temperature, and the associated compartment ambient temperature. When the temperature selection push button is released out, the temperature control system for that pack is achieved manually. The position of the temperature control valve is then controlled directly by the associated compartment temperature selector knob. When manual is selected, the manual caption will illuminate in the temperature selection push button. Click on the left temperature selection push button to continue. In the manual mode of operation, a temperature sensor downstream of the mixing chamber will limit the duct temperature to 88 degrees Celsius. If this temperature is reached or exceeded, a limiter will gradually close the temperature control valve so as to allow more cold air into the duct. Regardless of the mode of operation, if the duct temperature exceeds 92 degrees Celsius, the amber OVHT caption will illuminate in the associated temperature SEL push button. In addition, a single chime will sound, both master caution lights will flash, and an amber air duct OVHT message is displayed on the engine and warning display, or EWD. If the temperature out of the compressor section of the pack exceeds 204 degrees Celsius, the pack valve will automatically close, and a flight warning system or FWS caution will be triggered. This consists of a single chime. Both master caution lights will flash. The fault light will illuminate in the associated pack valve push button. An amber air pack message on the EWD. And the associated pack indicator is displayed in amber on the MFD cabin page. An external air card can supply conditioned air directly into the mixing chamber. This external air is plugged in through a connector located on the right side of the aircraft at the front of the fairing. The mixing chamber mixes the air produced by the air conditioning pack with air drawn from the cabin. The two packs are connected to the mixing chamber so that in the event of a failure of one pack, the remaining pack would be able to supply both the cabin and the flight deck. From the mixing chamber, the air is distributed throughout the aircraft. The output of the left pack goes mainly to the flight deck, whereas the output of the right pack goes mainly to the cabin. Any excess air from the left pack is used to supply the cabin. The cabin air is evacuated by two recirculation fans. The two recirculation fans draw air from the cabin and mix it with the pack air in the mixing chamber. This arrangement reduces the load on the packs. The recirculation fans are located in the underfloor area, just ahead of the wheel wells. By drawing air through the floor vents, the fans circulate air through the cabin, while keeping the floor temperature comfortable. What is not circulated by the fans is discharged overboard through the outflow valves. The recirculation fans are powered by the associated DC utility bus. In the event of an overload on the DC portion of the electrical system, the DC utility buses will be shed, and the associated recirculation fan will cease to operate. The recirculation fans are controlled by two recirculation fan push buttons located on the compartment temperature panel. When a push button is pressed in, the associated fan is operating. The fan rotation speed depends on the position of the associated temperature control valve. The recirculation fans will automatically run at full speed in the event the temperature at the floor level of the cabin is less than 18 degrees Celsius. In the event the fan speed is too low, or if the associated electric motor overheats, the amber fault caption will illuminate in the associated recirculation fan push button. In addition, a single chime will sound, both master caution lights will flash, and an amber air recirculation fan message is displayed in the EWD. The affected fan is indicated in the message. The flight deck, forward cargo compartment, and the electric and electronic equipment racks are ventilated using ambient air. This air is then recirculated to the pressurized compartment or exhausted overboard. The direction of the air is controlled by two valves: the underfloor valve and the overboard valve. A separate ventilation system is used to cool the flight instruments, floor-mounted batteries, and electronics racks behind the pilot seats. Air is drawn forward through the flight deck and into this ducting by an extract fan. Aft of the fan, the air is then dumped out the overboard valve. In this way, airflow from the flight deck is used to cool the flight instruments. The fan operates at one of two speeds, depending on the flight deck temperature. If the temperature is below 20 degrees Celsius, the fan will operate at low speed. If the flight deck temperature is above 52 degrees Celsius, the fan will operate at full speed. The fan speed will vary proportionally with the flight deck temperature if it is between these two values. An extract airflow lever is located on the right maintenance panel. This lever closes the extract airflow valve in order to stop air from flowing forward through the flight deck in the event smoke has been detected in the forward cargo compartment. During engine start, the extract fan will stop for 120 seconds to avoid pressure shocks through the aircraft. When the fan shuts down, the amber fault light in the exhaust mode push button, located on the avionics ventilation panel, will illuminate. Two valves direct the air drawn by the extract fan to either the underfloor of the aircraft or overboard. These valves are the overboard valve and the underfloor valve. The operation of the overboard valve is controlled by the overboard valve control switch, also located on the avionics ventilation panel. The overboard valve allows air to be discharged overboard. The overboard valve controls the operation of the underfloor valve. The overboard valve switch should be in the auto position in order to allow the proper operation of the underfloor valve. If the overboard valve control switch is in the auto position, The position of the overboard valve is a function of the exhaust mode push button, and whether the aircraft is on the ground or in flight. If the exhaust mode push button is pressed in, and the overboard valve control switch is in the auto position, the overboard valve will be fully open, and the underfloor valve will be fully closed. If the aircraft is on the ground, and engine 1 has low oil pressure, or is not running. In this situation, the extract fan will run continuously. The pressed-in position of the exhaust mode push button is a normal position for this push button. If the aircraft is on the ground with the number 1 engine running, or if the aircraft is in flight, the extract fan will run continuously, the overboard valve is fully closed, and the underfloor valve is fully open. This diagram shows the areas of the aircraft that are pressurized, and the areas that are not. 2 outflow valves are used to control cabin pressurization and cabin rate of change. One outflow valve is an electro-pneumatic valve, and the other is a pneumatic valve. The outflow valves are located on the bottom, aft portion of the fuselage, just forward of the aft entry door. Pressurization of the aircraft is achieved by controlling the amount of air that is exhausted overboard. The cabin and flight deck are pressurized through both the left and right packs. This inflow of air to the cabin is fairly constant throughout the range of power settings. The pressurization system can operate either in the automatic mode of operation or in the manual mode of operation. In the automatic mode, the pneumatic valve is slaved to the electro-pneumatic valve by an interconnected vacuum tube, which allows both valves to operate simultaneously. The outflow valves provides positive and negative pressure protection. Each outflow valve incorporates a manometric capsule which will open the outflow valve in the event the cabin pressure differential exceeds 6.35 psi. In the event the cabin pressure differential exceeds negative 0.5 psi, a non-return line will also open the outflow valve to relieve the negative pressure differential. Pressurization is normally controlled by a digital controller located on the center flight instruments panel. The digital controller calculates the reference cabin altitude for the existing flight altitude. The digital controller then uses a torque motor to position the electro-pneumatic outflow valve so as to maintain the calculated cabin altitude. The digital controller is powered by DC bus 1. The pressurization controller takes into account the departure field elevation, the destination field elevation, the existing cabin altitude, and the aircraft flight altitude in order to calculate the required cabin elevation. The pressurization controller uses information from the air data computers, or ADCs, to determine the aircraft's altitude. The barometric setting on the captain's altimeter is used for the calculations if ADC-1 is operating. If ADC-1 fails, the standard barometric setting of 1013 hectopascals will be used instead. The pressurization system is placed in the automatic mode when the mode selection push button on the cabin pressurization panel on the flight instruments is in the pressed-in position. This is the normal position for this push button. In order to operate in the automatic mode of operation, the cabin altitude knob must be in the normal position. The manual mode of operation is selected by releasing out the mode selection push button. When selected, the white manual caption illuminates in the push button, and an amber air automatic pressurization message is displayed on the EWD. In addition, the digits in the landing elevation window will extinguish, and the electro-pneumatic outflow valve closes. Once in the manual mode, the cabin altitude knob is used to directly control the pneumatic outflow valve. The cabin altitude knob can select any rate of cabin change from negative 1,500 to positive 2,500 feet per minute. Prior to placing the system in manual, you should set the cabin altitude knob position to a position between 9 and 10 o'clock. In this position, there will be no signal to increase or decrease the cabin altitude. Therefore, no pressure bump will be experienced when transitioning from automatic mode to manual mode. In order to understand how the automatic pressurization works, we will go through a sample flight. During the pre-flight, the crew will set the landing field elevation on the automatic pressurization panel. The landing field elevation is set using the elevation set toggle switch. This toggle switch is spring-loaded to the center position. The selected landing field elevation is displayed in the digital landing elevation window. The plus position of the toggle switch increases the landing field elevation, and the minus position decreases the value. A landing field elevation between -1,500 feet and +10,000 feet can be selected. Elevations can only be selected in 100-foot increments. Let us assume takeoff is from an airport with a field elevation of 20 feet above mean sea level. The destination field elevation is 900 feet. The flight plan calls for a cruise altitude of 20,000 feet. Click on the elevation set trigger switch to set the landing field elevation of 900 feet. Next, make sure that the cabin altitude knob is in the normal position. Click on the cabin altitude knob to place it in the normal position. The automatic pressurization system gets a signal from a landing gear micro switch, which determines how much the torque motor moves to apply vacuum pressure to the outflow valves after takeoff. The system then maintains the cabin altitude of the takeoff airport up to 3,500 feet, which we will look at more closely in a minute. During the climb, the digital controller will maintain a proportional pressure differential between the cabin altitude and the aircraft altitude. The controller will climb the cabin altitude at a maximum rate of 550 feet per minute. The pressurization system will maintain a maximum cabin differential pressure of 6 psi. If the aircraft is at flight level 250, the cabin altitude will be at 6,740 feet. When the aircraft starts to descend towards the destination airport, the digital controller will start to descend the cabin at a maximum rate of 400 feet per minute. For the landing, the pressurization controller will target a cabin altitude that is equal to the landing field elevation that was set during the pre-flight, minus 300 feet. After touchdown, the digital controller will then open the outflow valves, so as to increase the cabin altitude to the landing field elevation that was set during the pre-flight. During this depressurization phase, the controller will use a maximum climb rate of 550 feet per minute. Once the cabin altitude is equal to the landing field elevation, the outflow valves will be fully open. In the event you need to return to the departure airport after takeoff, the digital controller will instead use the departure airfield elevation minus 300 feet as the target cabin altitude for landing. This is called the automatic return feature. This feature is available up until the time the aircraft climbs 3,500 feet above the departure field elevation. At that point, the controller will use the landing field elevation that was set during the pre-flight. The maximum rate of descent can be changed by pressing the descent rate push button on the automatic pressurization control panel. When this push button is pressed in, the digital controller will use a maximum descent rate of 500 feet per minute. You should note that this push button has no effect on the maximum climb rate. The normal position for this push button is the released out position. The pressurization system can be placed in the manual mode of operation by placing the mode selection push button to the released out position. This will disable the digital controller, and the electro-pneumatic outflow valve will close. The white manual caption will illuminate, and an amber air automatic pressurization message is displayed on the EWD. Click on the mode selection push button to continue. The cabin altitude knob is used to manually control the pneumatic outflow valve. Using this method, the cabin rate of change can be changed from negative 1,500 feet per minute to positive 2,500 feet per minute. The crew will be responsible for maintaining the correct cabin altitude. We will now review the controls and indicators associated with the air conditioning and pressurization systems. The pack valve push button controls the operation of the associated pack valve. In the pressed-in position, the associated pack valve will open, provided electrical power and pneumatic pressure is available. The right pack valve will open after a 6-second delay for passenger comfort. In the released-out position, the associated pack valve is closed, the white off caption illuminates, and an amber air pack message is displayed on the EWD. The amber fault caption illuminates in the event the associated pack valve position disagrees with the commanded position, or if there is an overheat downstream of the pack compressor. In the event of an overheat, the pack valve will be latched closed. In the event the fault caption illuminates, you will also get a single chime, both master caution lights will flash, and an amber air pack message is displayed on the EWD. The flow push button controls the amount of pressure that is regulated by the pack valves. In the normal released out position, both pack valves will regulate pressure to 22 psi. In the pressed-in position, the flow push button will cause both pack valves to regulate pneumatic air pressure into the packs to 30 psi. The increase in pressure results in an increase of flow out of the pack. The cyan high caption illuminates in the push button when it is pressed in. Two indicators show the temperature in the selected compartment and associated duct outlet. The selection of which zone that is measured is made by the compartment selection toggle switch. The switch allows the crew to check the zone temperature and the duct temperature for the flight deck or the cabin. The temperature selection push button controls the mode of operation of the pack. In the pressed-in position, the associated pack is operating in the automatic mode, and the desired temperature is selected by the compartment temperature selector knob. In this mode, the electronic temperature controller maintains the desired compartment temperature. In this mode, the associated duct temperature will be limited to 88 degrees Celsius. When the temperature selection push button is released out, the compartment temperature selector directly controls the temperature control valve of the associated pack. The white manual caption illuminates in the push button. In this mode, the associated duct outlet temperature is also limited to 88 degrees Celsius. The amber overheat caption illuminates in the event the associated duct temperature exceeds 92 degrees Celsius. In addition, a single chime will sound, both master caution lights will flash, and an amber air duct overheat message is displayed on the EWD. The recirculation fan push buttons control the operation of the associated recirculation fan. When a push button is pressed in, the associated recirculation fan will operate. The fan speed is then dependent on the position of the temperature control valve. In the released-out position, the associated recirculation fan is deactivated, and the white off caption illuminates in the push button. In addition, an amber air recirculation FAN message is displayed on the EWD. The message will indicate the affected fan. In the event a recirculation fan overheats, or it has low RPM, the fault caption will illuminate in the push button. This will be accompanied by a single chime, both master caution lights will flash, and the amber air recirculation FAN message is displayed on the EWD. The message will identify the affected fan. The overboard valve selector switch controls the operation of the overboard valve of the avionics vent system. In the auto position, the avionics vent system will operate automatically. In this mode, the position of the overboard valve is dictated by the exhaust mode push button selection and the phase of flight. In the full close position, the overboard valve will be fully closed. Placing the switch to the full open position will fully open the overboard valve. You should not open the overboard valve if the differential pressure exceeds 1 psi. Opening of the overboard valve while in flight will result in a depressurization of the cabin, as well as a possible collapse of the overboard duct. The exhaust mode push button controls the operation of the exhaust system, provided the overboard valve switch is in the auto position. The pressed-in position of this push button is the normal position. In the pressed-in position, the operation of the extract fan, the position of the overboard valve, and the position of the underfloor valve depend on whether the aircraft is on the ground or in flight. If the aircraft is on the ground, and there is low oil pressure on the number 1 engine, the extract fan will run continuously, the overboard valve will be fully open, and the underfloor valve will be fully closed. If the aircraft is in flight, or on the ground with the number 1 engine running, and the overboard valve selector switch in the auto position, the extract fan will run continuously, but the overboard valve will be fully closed, and the underfloor valve will be fully open. Placing the exhaust mode push button to the released out position will turn off the extract fan. This mode would be used in the event the extract fan overheated, or was running at too low an RPM. In this mode, the cyan overboard caption will be illuminated in the push button. In addition, both master caution lights flash. A single chime sounds. An amber air ventilation exhaust message is displayed on the EWD. And a cyan exhaust overboard label is displayed on the MFD cabin page. If the exhaust mode push button is released out while the aircraft is on the ground, with a ground power unit powering the aircraft, a ground mechanic call will be triggered, and the horn will sound continuously. Since the fan will be turned off, there will be no airflow through the compartments, which will result in an overheat condition. In addition, as before, the master caution lights will flash and a single chime will sound. If the condition levers are not in feather or fuel shut off, an amber air ventilation exhaust message will be displayed on the EWD, and an exhaust overboard label is displayed on the MFD cabin page. If you recall, the extract fan will stop for 120 seconds during engine start. In this case, the fault light will illuminate, but the ground mechanic horn will not sound. The fault caption illuminates in the event of a failure of the extract fan, or there is a fan overheat. If the fault caption illuminates, you will also hear a single chime. In addition, both master caution lights will flash, and an extraction fan icon is displayed in amber on the MFD cabin page, along with an exhaust ventilation label. The overboard valve fault light illuminates in the event the overboard valve is not in the commanded position. On the ground with low oil pressure on engine 1, the fault light will illuminate if the overboard valve is not in the full open position. The fault light will not illuminate if the overboard valve selector switch is in the full close position. You should not confuse the overboard valve fault light with the fault light on the exhaust mode push button. If the aircraft is on the ground with engine 1 running, or if the aircraft is in flight, the fault light will illuminate in the event the overboard valve is fully open, and the overboard valve selector switch is not in the full open position. Regardless of the reason for the illumination of the fault light, the light will extinguish in the event the overboard valve goes to the commanded position. Illumination of the fault light will result in a single chime, both master caution lights will flash, an amber air overboard message is displayed on the EWD, and an amber overboard label is displayed on the MFD cabin page. The mode selection push button on the cabin pressurization panel selects the mode of operation of the pressurization system. In the pressed-in position, the pressurization system will operate in the automatic mode, and cabin pressurization is controlled by the digital controller. Placing the mode selection push button in the released out position will select the manual mode of operation. The cabin altitude knob should be placed in the 9 to 10 o'clock position prior to switching back and forth between the automatic and manual mode. In the manual mode, the white manual caption will be illuminated in the push button, and the amber air automatic pressurization message is displayed on the EWD. The amber fault light illuminates in the event of a failure of the digital controller. In addition, a single chime will sound, both master caution lights will flash, and an amber air automatic pressurization message is displayed on the EWD. The guarded ditch push button is used to prevent water from entering the fuselage in the event the aircraft is ditched. Pressing this push button forces both outflow valves to the fully closed position, regardless of the mode selection push button selection. When pressed in, the white on caption illuminates in the push button. In the ditch mode, 2 electric motors maintain both outflow valves in the closed position. There is one motor for each outflow valve. Both motors are powered by the DC emergency bus. When both outflow valves are in the ditch position, the flight warning system will be activated. This will result in a single chime. Both master caution lights will flash, and an amber air ditch message is displayed on the EWD. The guarded dump push button on the automatic pressurization panel is used to dump the cabin pressure. In the released out position, the digital controller will operate normally. When the dump push button is pressed in, the digital pressurization controller will be disabled, and an electrical signal will fully open the electro-pneumatic valve. In turn, this will cause the pneumatic outflow valve to fully open as well, and the cabin pressure will be dumped. When pressed in, the white on caption illuminates in the push button. The dump mode is only available in the automatic mode. The test button electrically tests the pressurization system. The indications of a successful test are the numbers 18,800 and -8,800 alternating in the landing elevation window. In addition, the amber fault caption illuminates in the mode selection push button. It should be noted that the test function of the pressurization system is inhibited when the aircraft is in flight. The air conditioning and pressurization systems are displayed in graphical format on the MFD cabin page. Cabin altitude rate of change, and cabin pressure differential are displayed on the bottom of the page. The packs are represented by a rectangle with a white pack label inside. The color of the rectangle indicates the status of the pack valve. Green indicates that the associated pack valve is selected on, and white indicates that it is selected off. When off is selected, the label inside the rectangle changes to pack off. A fault is indicated by an amber rectangle and a pack fault label, with the fault line displayed in amber. A pack standby label with a green rectangle indicates that the associated pack switch is selected on, but there is no bleed air available to open the valve. The temperature control mode is displayed on the inboard side of each pack icon. A green auto label indicates that the associated pack temperature control is in the automatic mode. A cyan manual label indicates that the associated pack temperature is controlled manually. An amber overheat label indicates that the associated duct is overheating. If the flow push button is pressed in, the packs will be delivering high flow. This is indicated by a cyan air high flow label in between the two packs. The temperature of the air measured downstream of the packs is indicated in numerical format. The temperature is normally displayed in green. Amber dashes indicate that the sensor is reporting an invalid value. The two recirculation fans are represented by two circles. Green indicates that the associated recirculation fan is selected on. White indicates that the associated recirculation fan is off, and amber indicates a fault. The white recirculation label in between the fans indicates that one of the two fans is off, whereas an amber label indicates that one of the two fans has a fault. The distribution lines are displayed in green when both pack valves or both recirculation fans are on. The bottom, right-hand side of the lines is white if the left pack valve and the recirculation fan too are off or have a fault. If the right pack valve and recirculation fan 1 are off or have faulted, the bottom, left-hand side of the lines is displayed in white. The lines are white if both pack valves and recirculation fans are off, or there is a fault on both sides of the system. The MFD cabin page also shows the status of the extract fan and the overboard valve. The extract fan is represented as a green icon when it is operating. A cyan exhaust overboard label is displayed along with a gray and white icon when the exhaust mode button is released out. A fault in the extraction fan is represented by an amber exhaust fault label and a gray and amber icon. The position and status of the overboard valve is indicated by a small line. The bottom dial on the left shows the pressure differential between the cabin and the outside. The current differential pressure is indicated by a needle against a dial, and in numerical format. The needle and numerical indications turn amber when the differential pressure is in the caution range. When a limit is exceeded, the needle turns red, and the numerical value is displayed in white on a red background. Amber dashes indicate an invalid differential pressure measurement. The cabin rate of change is displayed in the dial on the right side. The rate of change is indicated by a needle against the dial, and in numerical format. Amber dashes indicate an invalid value. The mode of operation of the pressurization system is indicated on the left side of the cabin altitude. Automatic pressurization indicates that the system is in the automatic mode. Green indicates that the system is operating normally, and amber indicates a fault in the system. Manual altitude means that the pressurization system is being operated in the manual mode. In this mode, a target altitude is displayed in magenta under the current cabin altitude. The current cabin altitude is indicated in numerical format between the two dials. The cabin altitude is normally displayed in green. It is displayed in amber when the current cabin altitude is approaching the maximum limit. It is displayed in white against a red background when the maximum cabin altitude is exceeded. Amber dashes indicate an invalid value. The maximum differential pressure is 6.35 psi. The outflow valves will open if this differential limit is exceeded, and the cabin altitude will climb to relieve the pressure. In addition, both master warning lights will flash, the continuous repetitive chime sounds, the red excess cabin delta P message is displayed on the EWD, and a cabin delta P label is displayed on the MFD cabin page. If the cabin altitude exceeds 10,000 feet, both master warning lights will flash, and you will hear a CRC. In addition, the red excess cabin altitude message is displayed on the EWD, and a cabin altitude label is displayed on the MFD cabin page. The indication is white on a red background. The digital controller will fully close both outflow valves if the cabin altitude exceeds 13,000 feet. The maximum negative differential pressure is negative 0.5 psi. The maximum differential pressure for landing is 0.35 psi. The maximum operating altitude with one bleed system operative is 20,000 feet. This concludes the air conditioning and pressurization module.